Hello everyone and welcome back to the ccubed channel. This is a tier 1 video, meaning that this is aimed for GCSE Maths Foundation students doing the Edexcel exam board, and it's also could be useful for people who wish to start maths from the ground up. So today's topic, it will be talking about expanding and factorizing linear expressions. So this is kind of, again, an expansion of what we've done in the last two sessions to, putting like terms together and looking at expressions in general. So we're going to be branching a bit further. We're going to be learning how to kind of manipulate more of the bracket side, more of the multiplication side of things. So quickly, we're going to very briefly go back over the parentheses notation or the brackets notation. We're going to quickly recap on this. So we've said in the first session that you can write 2 times 5 as 2 and then brackets 5 and then brackets. So that basically just means 2 times 5. So this is just another way of writing 2 times 5, except instead of getting rid of now you just get rid of the times sign and you put the brackets around the 5. Meaning that you're doing 2 multiplied by whatever's in the bracket, which is 5. So, better example we could say is 2 times 5 plus 1. So in this case you can actually just get rid of the multiply sign here and just leave it as this, and this basically is just exactly the same as this. So this is basically just 2 times everything in the bracket, so 5 plus 1. And we can take that a step further, so we know that we remember what we said was 2 times x, and we remember that when you multiply in algebra with with letters and unknown variables, you don't need the multiplication symbol, so we just have 2x. But remember, we also just now said that you can write 2 times x as 2 and then x in brackets. So you have 2 times x, or 2 times everything in the bracket, which is that. And in this case, if you simply multiply 2 with x, you just get 2x. So these are 3 different ways of writing exactly the same thing. But in algebra, you would use these 2. These are the ones you'd see more often. So using this in mind, we have basically done something called expanding brackets. So we've done expansion, basically. And we're going to look a little further into that now. So expanding brackets is basically just a simple way, it's just a way of multiplication, really. You're multiplying something by something else. That's all this is. And in order to get a final value, you have to go through a process called expanding brackets. So the general process of this is quite simple, and it's quite easy. There isn't too much to it, especially with the linear stuff, because these are all linear expressions right here, and then the next few slides as well. But when you go further on, when we go into quadratic stuff, cubic, quartic, whatever, in the future, then the same application kind of applies. We just do the same kind of method, it's just longer. So this is a foundation for a lot of algebra stuff that you'd find everywhere in maths and physics. So the general process of doing this is quite simply, we take the value outside the brackets, so in this case 2, and we multiply it by each individual term inside the brackets. We do it one by one. So what I mean by this is we have 2 times x plus 1, right? So 2 times everything in the bracket. So in order to expand this out, what you do is you would do 2 times x first, which we know is 2x, and then 2 times plus 1, right? So 2 times 1, basically, or plus 1, is just 2. And so we carry the plus over and have it as plus 2. So what we did was we did 2 times x, and then we did 2 times 1 as well. And always remember the sign, as you'll see in the next one, the sign matters as well. So this is just the process of expanding brackets. So we've got from this that is equal to 2x plus 2. That's all there is to it. That's it. So we can do the next example here. So 3 times x minus 2. So again, we're going to begin doing expanded brackets. So 3 times x is 3x, And then we got 3 times minus 2. Remember we gotta consider the sign as well. So 3 times minus 2 is minus 6. So take the minus into account right there. Okay? So that is pretty much it with this. That's kind of the general process of expanding the brackets, honestly. It's just you take whatever's outside, you multiply it by the first term, and then you multiply the same one by the second term, and then that's what you get is the answer. So 2 more examples of this. Let's do a bit of a harder situation here. So we now have minus x on the outside as the initial term, and we're going to multiply it by 2x and 1. So minus x multiplied by 2x plus 1. So in this situation, we just simply do minus x times 2x, and that is equal to minus, let's put equals, minus 2x squared. Because remember, x times x is x squared, as we've learnt in the last video with indices, laws, and in the first video as well. So minus x times 2x is minus 2x, because it's 1 minus 1 times 2, which is the minus 2 there, and you got x times x, which is the x squared. And then we do it again, minus x multiplied by plus 1, and that is equal to minus x. It's about to say 1 for a moment, but yeah, so minus x times 1 is just minus x. And then that's our final answer, minus 2x squared minus x. Now, as we'll learn in the next part, we'll see how to kind of, make that a bit neater. Not with this example, but with a different kind of example. So, to end it off with this, we'll just have a general cases. So if we have 4 different variables now, a multiplied by bx plus c. So a, b, c are different number. All of these could be any number, anything. And if we want to expand this out, again, you can kind of guess, is just quite simply a times bx, which is a, b, x, and then multiply a again by c, and you just get plus a, c. And that is the general case of this kind of, this kind of thing up here. So this is what it will be. Something of this kind, pretty much. So this is just, examples of how to expand brackets. They all follow exactly the same principle. Always multiply first by second and then first by the last. Always the same general method. So this is quite easy to, master. You can just do a bit of practice and you should get it. Now we're going to take a look into factorization. Alright, so factorization is basically the reverse of expanded brackets, so reverse of expansion. So if we have something like this, we want to get it back into that form there. Right? So let's take this first example here. 2 plus 4x. Okay. So we want to get that into a simpler form. So basically this is a process of just making it as simple as you can. So we know, the first step is to look at where you have common factors. So basically is just where do you see numbers, going into both of the terms. So for example, we can see with the very beginning here, 3 was going into both x and 2. Because you see you got 3x and you have 6, and they're both multiples of 3. You understand? You see what I mean? So if we have 3x, that's 3 times x, and then minus 6 is 3 times minus 2. So 3 appears in both cases, and that's why 3 appears on the outside. So we could do the same here. In this situation, 2 appears to be the common factor here, because 2 appears in both cases. So you got 2 on its own, you have 2 times 1, and then you have 2 times 2. So all we could do is we could take 2 out as a common factor, got bracket, and then remember, we can actually just divide over here. So 2 divided by 2 is 1. Right? And then 4 divided by 2 is 2. And of course the x stays because there's no x here. So 4x divided by 2, I should say, is 2x. Right? and then that's factorized. If you want to double check to make sure that is correct, you can simply just expand this out again. So you'd have 2 times 1, and then you'd have 2 times 2x, which is 4x. And as you can see, that is exactly the same as that. So that means this is factorized out correctly. And that is the factorized form of that expression. So the next 3 examples, we're going to be taking a look at this a bit further. So with the next example now, we have x squared plus x. And we have to find the common factor here. So in each case, you can see x appears in both cases, right? One is x squared and the other one is just x. So we can take from this that x is the common factor. So we take x out. Alright? X goes out here. Alright, now, in order to get what's inside, we do x squared divided by x. Now remember, we said that x times x, that's a bad times, but you get the idea, is x squared. So if you want to divide x over, you're just going to get one of the x's. So you just simply get x here. Because x times x is x squared. If you get what I mean here. So that's what it is. And then with the second term, we do x divided by x, which is simply 1. And that is what you get for the factorized form. That is the simplified factorized form right there. So again, to check if this is correct, we do x times x, which is x squared, and x times 1, and then add on is x. So x squared plus 1. X squared plus x, and that's exactly what we get right there. So that is factorized, and that works. So the final two examples here, we have 3x plus 9 plus 3z. Now in this situation, we have 3 terms. Now I have done examples with only 2 terms in both, expansion and factorization. We've only done 2 terms here, but you can have more terms. And if you had an extra term in here, for example, let's say 2x plus y plus 1. So if you had that instead, the process is exactly the same. You just do 2 times x plus 2 times y plus 2 times 1. So basically, just multiply the outside number by every single individual term. If you had 4 of them, you do this 4 times. If you had 5, you do it 5 times. Etc. So we'll see how to do it now. This is like the simplest expansion method. There are more that gets a bit more in detail, but we'll look at it later, especially when we get into quadratics, and that's when you have to do a slightly different approach. But the general process is this, for the time being, if you have just a single number or variable outside. So, going back to this real quick, so if we want to factorize this out, let's take a look at all the common factors in here. So we got 3, 9, and 3. So you can see 3 goes into all 3 of them. So in this case, 3 goes on the outside. And then once again, we do the process again. 3x divided by 3 is just x. And then we do plus. 9 divided by 3 is 3. And then 3z divided by 3 is just z. And that is a factorized right there. Done. And again, if you want to double check if this is correct, you just multiply each term individually. So 3x becomes 3x, 3 times x becomes 3x, 3 times 3 becomes 9, and then 3 times z becomes 3z. So it works. And now finally for the last case. Now, in this situation we have ax plus bx plus cx. Now, this is quite an interesting one. We can immediately see straight away x appears in all 3 of them. So x is going to be the common factor here. And now again, we just do the same process, ax divided by x, bx divided, to see which, each term would have. So x divided by x is a, bx divided by x is b, and then cx divided by x is c. Now what's interesting here, we said previously, in the first video that, when you have, now these are all like terms, all of them, because they contain x, right? So these are actually all like terms here, we haven't seen this with the other ones, but we have seen it here. These are like terms. And remember what we said with like terms, when you add them up, you just simply add the numbers up, which these are called coefficients in front of them. But you just simply add these up together, yeah? And that's a trick because you can't really, it's kind of a practical example of this, actually. So, what we've done here is we've actually technically added the three of them together, which is right there, A plus B plus C. So if you, let's say you make A1, B2, and C1, so it'd be X plus 2X plus X, and that is equal to 4X. And then, if you put it here instead, it'll be 1 plus 2 plus 1, and that's equal to 4. And X times 4 is 4X. So, this is kind of a proof of the addition rule that we saw when it comes to like terms in the first video. And we can see that simply through factorization as well, that you get the same kind of approach here. So this is a very useful method as well. This bit down here is quite an essential tool you can use for the future. So just something good to keep in mind. Okay, so that is all I had to say on factorizing and expanding linear expressions. There isn't too much to this. It's quite basic, and it's basically the same kind of process all the time. The next video, we're now going to be taking a look a bit further, and we're going to be looking at actually solving some equations now, using all these things that we've done so far. So that's for the next video. But anyway, thank you guys so much for watching, and I'll see you all in the next video.